Welcome back on our series Introduction to Calculus. Last video we looked at what an equation and a norm, what a tangent and a normal were in terms of the visual aspects of it. What we're going to be looking at in our next series is actually finding the equations of those tangents and norms. So remember, if I had a graph here, and just say I had this graph, and I wanted to find the tangent at a particular point. Say this here was x is equal to 2. I can work out what the equation of this tangent line is when it touches that gradient at this point. So what this whole exercise here is working out, well, what is the equation of this line at the exact point the gradient is occurring at this curved line. So let's get into this first example. It's saying here, find the tangent to the curve y equals x cubed minus x at the point where x is equal to 1. So when we're looking at these types of questions, we are going to be using an equation later on where we are going to need both our x1 and our y1 equations, or our data. So the first thing we want to do here is, well, we know what x1 is. Let's find out what the y equivalent of this function is when we plug x into it. So when x equals 1, y would equal 1 cubed minus 1, which is equal to 0. So therefore we can write up here y is equal to 0. So when x equals 1 on that graph, in that point, y is equal to 0 at that exact same point. So this here is the first thing that we do. So we find the y coordinate first. So find y coordinate. And the next step we're doing here is, well, it's asking us to find the tangent. So we've got to find a gradient of this. So therefore we've got to differentiate this equation. So your second thing here is, let's differentiate y equals x cubed minus x. So if we differentiate this, we've got dy dx is equal to 3x squared minus 1. And this here is the gradient. So if we're looking at the curve x cubed minus x, this here is the gradient of that curve. I don't know where it's at that point, but we're just saying this here is the general gradient of the curve. We now want to work out, well, what is it at that exact point? Because we're trying to find the equation of the tangent when it touches the curve at x equals 1. So what we do here is, we find out what the tangent is. So we find the gradient of the equation of tangent. So in this case, we're just plugging in 1 into this gradient function. So when x is equal to 1, we get 3 times 1 squared minus 1. So therefore 3 times 1 is 3, minus 1 is 2. So therefore we say that the gradient of the tangent is, when x equals 1, is 2. So if we look at that graph again, we're saying when x equals 1, at this exact point when I'm touching it with the tangent line, it has a gradient at x equals 1 of 2, at that instantaneous point. And that's what we've found in this part here. Well, the last part of the question, which doesn't say it in this part, is we now need to find the equation that uses all this information together to give us what that straight line is. So we need to now find the equation of the tangent. And we have a special rule that we can use here. And this rule here is y minus y1 is equal to m brackets x minus x1. And that's why at the start I said, well, we need to find out what y1 and x1 is so that we can plug into a formula later on. So we now know three parts of this information. We know that y1 is 0, so I can replace y1 with 0. I know that my gradient is 2. And I know that x1 is 1. So I've now written up my equation in terms of what it could possibly be. Let's now just simplify it out. Y is equal to, that doesn't exist, expand our brackets, 2x minus 2. So therefore, the equation of the tangent line that touches this graph at x equals 1 is 2x minus 1. So we have to differentiate this first to work out the equation that touches it at the gradient of 2. Alright, I'll see you in the next one.